All right, hi guys, welcome to your first virtual learning experience. I'm excited to see how this all goes, but it's new for you, it's new for me. We might have some bumps along the way, so if you're ever having any technology issues, please reach out to me via email. If you're ever just not understanding the material that we're going over, that's okay. Please reach out to me for those concerns as well. So what I'm gonna have you do anytime we have math class virtually is, if you're watching a video, always make sure you have a pencil, a piece of paper, and a calculator. Not sure if we'll always need the calculator, but it's always good to have. It's totally fine to use the calculator on your computer. Okay, so what we're gonna do today is a little bit of review of equation solving, and then we're gonna move into something a little new. We'll see how it goes, and if you have trouble, just let me know. All right, so let's clear the screen and let's get started. So the first problem I'm going to toss to you is something that we could definitely do pretty easily. So the problem is going to be 9x minus 12 equals 24. All right, pause the video, try it out, and write down your answer. So now I'm going to show you how I would solve it. This one's pretty straightforward. So first step in isolating x would be to add 12 on both sides. When we add 12 on both sides, 12 goes away on this side of the equation. The equation becomes 9x equals 36. And then to finish the equation, we're going to divide both sides by 9. So x is all on its own. Then we do 36 divided by 9, which equals 4. And that's our answer. Hopefully that's what you got. If not, maybe you made a mistake along the way. Just look at the work I did. Hopefully that will help. All right. Moving on to our next problem of the day. It's going to be, and write this down as I go, 2x minus 7 equals 3, and then in parentheses, x minus 9. All right, we're going to pause the video, and you're going to try to solve it. Okay, so now that you've tried to solve it, let's see if you got my answer as well. So the first thing we're going to do here is we're going to distribute the 3 to everything inside. That's going to make the equation become 2x minus 7 equals 3x minus 27. Okay, from this stuff, there's a couple different ways you can go next, but I'm just going to show you the way I would have gone next. I would have subtracted 2x on both sides, so I get all the x's on that right side of the equation, because 2x would eliminate that side. I'd be left with negative 7 equals x minus 27. And then from here, I would add 27 to both sides. 27 would go away on this side, leaving me with 20 equals x, and that would be my answer. All right. Now the whole process of solving an equation deals with operations and their inverse. So for every operation we know, it has an inverse. Addition is an operation, and its inverse is subtraction. Subtraction has an inverse, which is addition. Multiplication has an inverse, which is division, and division's inverse is multiplication. We've known this. This is not new information, and this helps us solve equations. But these are not the only operations we know. When we think about the order of operations, PEMDAS, PEMDAS, we've addressed addition, subtraction, we've addressed multiplication, division rather. Parentheses are not so much an operation as a ordering tool, but the operation we haven't talked about is exponents, which comes before all of these other operations. So this is what we're going to focus on today. We're going to focus on exponents, specifically to raising anything to the power of 2 and the inverse of that operation. So let's look at raising things to the power of 2. 1 to the power of 2, 2 to the power of 2, 3 to the power of 2, 4 to the power of 2, 5 to the power of 2. These are something we can do. 1 times itself is 1. 2 times itself is 4. 3 times itself is 9. 4 times itself is 16. 5 times itself is 25. Whoop. Now, what all of these numbers are called is they are called perfect squares. They're called perfect squares because whenever you raise a number to the power of 2, it's called squaring something. 5 to the power of 2 is also known as 5 squared. 3 to the power of 2 is 3 squared. So the result of any of those operations, taking a whole number and raising it to the power of 2, or squaring it, is called a perfect square. Can you list, I don't know, let's go with 4 additional perfect squares. All right, so something you might have come up with was 49, 100, 144. There's a whole bunch. They go on forever and ever, but they have a special relationship. So perfect squares are numbers that are really convenient, but what we want to be able to do is be given a perfect square and figure out what number created that perfect square. So what number times itself gives you 49? What number to the power of 2 gives you 49? What number to the power of 2 gives you 100? What number to the power of 2 gives you 144? Now, what you're doing here is actually you're finding the square root. So in this case, we know 7 squared equals 49, we know 10 squared equals 100, and we know 12 squared equals 144. But the process of undoing the squaring, or taking something and raising it to the second power, is called taking its square root. So instead of verbally explaining it, the way we write that in math lingo is, let's say I wanted to figure out what number times itself equals 36. I would do the square root of 36, and the square root of 36 is 6. The square root of 64 is 8. What is the square root of 81? Right, it's 9. And why is this helpful? Why am I showing you this? Well, it's helpful when we start using equations that have things raised to the second power. So let's say my equation looks like this. X squared equals 9. And what I wanted to know was, what is the value of x? Well, in order to undo or use the inverse operation of squaring, I will take the square root of this side. So all I'm left with on this side is x. And whatever you do to one side of an equation, you have to do to the other. So I'd have to find the square root of 9. The square root of 9 is 3. So that's going to be my answer. Now you give it a try. X squared equals 121. What's the value of x? Right, it's 11. Very good, because we take the square root of each side and we get x equals 11. So let's see when we bring that up a level. What if I give you the equation x squared plus 7 equals 107? Well, the first step in this process is the same as equation solving. We want to isolate the variable. So the first thing we're going to do is we're going to subtract 7. When we've subtracted 7, this has undone itself. And we're left with x squared equals 100. Well, to find x, we have to take the square root of this side to get rid of the squaring. And whatever you do to one side, you have to do to the other. So we take the square root of 100, which is 10. All right? Now, let's see you give it a try. X squared plus 9 equals 90. Let's see if you can figure out what x is. Okay, so let's see how we would do this. This situation, we would subtract 9 from both sides. And we'd be left with x squared. That gets eliminated, equals 81. We would take the square root of both sides, resulting in x equals 9. But what happens when the numbers don't work out so nicely? What if I have x squared plus 5 equals, let's go with 25. So what happens here is same approach. We're going to subtract 5 from both sides, and we get x squared equals 20. Oh no. Why is this a little bit different from every problem we've done already? The reason this is different from everything we've done already is when we take the square root of both sides, this side becomes x, but we don't have a whole number that is the answer to the square root of 20, so we have to keep it as a square root, where it says the square root of 20. However, this is very similar to when you have a fraction written wrong. And what I mean by that is like this is like keeping the number 8 over 12 instead of simplifying your fraction into what? What would this reduce into? Right, this becomes 2/3. This is the proper notation. So what we have to do is we have to learn how to take something like the square root of 20 and write it in its simplified form. So let's try to show you how that happens. If I want to figure out how to write the square root of 20 in a simplified way, what I first have to figure out is all of its prime factors. So we're going to make a factor tree. So the factor tree of 20 would break it into 2 and 10. Whenever you get a prime number, I want you to circle it. 2 is prime, 10 is not. 10 can be factored even more. 10 then gets factored into 2, which is prime, and 5, which is also prime. So the square root of 20 can be rewritten as the square root of 2 times 2 times 5. Well, the whole point of a square root is to find groups of numbers multiplied by itself. And I see 2's multiplied by themselves. Whenever you see a number being multiplied by itself inside a radical, it can leave the radical as 1. So because 2 is getting multiplied by itself, it can actually leave the radical as itself, just one of them, and 5 had nothing left. So that would be how I write the square root of 20. The square root of 20 in its simplified form is 2 square root of 5. Now, that might be new and a little bit tricky, but the real key to this is the factor tree. So we're going to do a couple more to try to practice. First one we'll do is the square root of, and let's pick a number. Let's do the square root of 72. Now, I see that it's an even number, so even if I don't know a whole lot about it, I know for sure it can be broken down into 2 and something else. What number does 72, when divided by 2, become? 72 divided by 2 is what? Right, it's 36. Now we're going to circle every time we get a prime number. So now I'm left with 36. And now 36 has something special. 36 is a perfect square. It breaks down into 6 and 6. So if I rewrite the square root of 72 as 2 times 6 times 6, I see 6 times 6 being multiplied by itself, so they can leave the radical. They leave the radical together as one. I like to say it's like they're leaving the house and getting married together so they become one. I know it's kind of silly, but it's what always made sense to me when I learned this. So they leave and become one, just 1 6 outside the radical, and there's still that 2 left inside. Now, If you notice here, I didn't break it down into prime factors because I found a perfect square already. I could have broken this down more, but this was a little bit of a simpler way. Let's do one more. So we're going to do the number 44. All right, so 44 can be broken down into 4 and 11. 11 is prime, but 4 is not. So 4 gets broken down into 2 and 2. Each of those are prime. Making this, oh, sorry, I should have said we were breaking down the square root of 44. That's my bad. So now I have the square root of 44 equals the square root of 2 times 11. 2 and 2 can leave the radical as 1, and the 11 has to stay inside the radical still. So 2 radical 11 is your answer. So what I want you guys to do now is there's a couple extra practice sheets on Google Classroom. There's just like 5 more I want you to give the best try to. I'm not going to have it collected, just see if you can practice with those problems because they're going to make more sense for the lesson we do next time. So until I talk to you guys again, thanks so much for making it through this first lesson. If you have questions, please reach out and we'll go from there. Have a great day.